In this video, we are going to solve a problem about fluid flow measurement, determining the flow direction in a horizontal pipe based on the pressure in diameter data. Our problem is the pressures at two sections of a horizontal pipe are 0.3 kg force per centimeter squared and 0.6 kg force per centimeter squared, and the diameters are 7.5 cm and 15 cm respectively. Determine the direction of the flow if the water flows at the rate of 8.5 kg per second. State your assumptions. We have given pressure at section 1, 0.3 kg force per centimeter squared. Pressure at section 2, 0.6 kg force per centimeter squared. Diameter at section 1 is 7.5 cm or 0.075 meter. Diameter at section 2 is 15 cm or 0.15 meter. And the mass flow rate is 8.5 kg per second. In this problem, we are going to use two equations. First is the equation of continuity. Second is the Bernoulli's equation for a horizontal flow from section 1 to section 2. Let us break down the calculation step by step. First, we will calculate the volumetric flow rate. First is we will convert the mass flow rate to volumetric flow rate. So our volumetric flow rate is 0.0085 cubic meter per second. Next, calculate the velocity at both sections using the volumetric flow rate and the diameter. For section 1, flow velocity is equal to volumetric flow rate over the cross-sectional area of the pipe. Now let us input the volumetric flow rate, which is 0.0085 cubic meter per second. For the cross-sectional area of the pipe, we have the given diameter for section 1 or the pipe 1, 0.075 meter. So pi d squared over 4. So pi 0.075 meter squared over 4. So the flow velocity for section 1 is 1.924 meter per second. Now let us proceed for the section 2. Same lang din yung equation na gagamitin natin, pero i-change lang natin yung value ng diameter for the cross-sectional area of the pipe. So the diameter of pipe 2 is 0.15 meter. If we will calculate the flow velocity, we will get 0.481 meter per second. Therefore, the flow velocity for section 2 is 0.481 meter per second. Next is we will convert pressures. 1 kilogram force is equal to 9.80665 Newton. 1 centimeter is equal to 0.01 meter. 1 centimeter squared is equal to 0.0001 meter squared. Thus, 1 kilogram force per centimeter squared is equal to 98,066.5 Newton per meter squared. And pressure 1, we have 0.3 kilogram force per centimeter squared. If we will convert it into Pascal, we can get 29,419.95 Newton per meter squared. In pressure 2, we have 0.6 kilogram force per centimeter squared. In Pascal, we can get 58,839.9 Newton per meter squared. Since yung problem natin, nagsabi na mag-state daw tayo ng assumption. So, we will assume the flow direction is from section 1 to section 2. We will apply the Bernoulli's equation. We will simply substitute the pressure, the flow velocity of section 1 and section 2 to our Bernoulli's equation. Since na input na natin yung mga given data, we will solve for the height. 0 yung W and Q natin kasi wala man tayong heat transfer and also there is no work is done by our fluids. So, no work is done. This implies that the fluid is not doing any mechanical work. And sa no heat transfer naman, this means that there is no heat being added to or remove from our fluids. Given W and Q are 0, so 2.9436 meter plus 0.189 meter is equal to 5.8872 meter plus 0.0118 meter plus H. So, ilipat lang natin yung H sa kabila. So, 3.1326 meter minus 5.899 meter is equal to negative 2.7664 meter. Since H or the height cannot be negative, our assumption is incorrect. Thus, the flow direction is from section 2 to section 1.